Hello, in this video we are going to talk about circles, their standard equations, and how to get the standard equation from the general equation of any conic section. And so in this first step here, we're going to come up with the standard form with knowledge that we already know about the Pythagorean theorem in triangles. So we have this circle drawn out here. It has a radius of r, and we've picked out a point that is on the circle, and this point we've called it x0. And then we have the center, which is 0, 0, and so that would mean this point here has the x coordinate, which is x, and y is 0. So there's our 3 points, and then together they make our triangle, which has the hypotenuse equal to r. We have x along the x-axis and a length of y along the y-axis, because that's how high it is according to that point. And so we're going to use Pythagorean's theorem to write an equation for r, which means we would have to take x squared plus y squared, and that would equal r squared. Remember, the hypotenuse is always on its own on the other side, and the two legs are together being added. Now on this next part, we're going to still use Pythagorean's theorem just like we did here. However, the center is no longer 0, 0. So 0, 0 was over here. Now the circle has been shifted over to this center point, which we don't have any exact values. We're just calling it HK. So that means it's h distance along the x-axis and k distance along the y-axis, so then that brings you to that center point. But the radius is still the same for this circle. It still has a radius of r. So that would mean we have this point here on the circle, which again we will call xy, and that would mean this other point. And if we go horizontally from the center, it would have to be xk, because it has the same x coordinate as this point, right, x distance there, but it has the same y coordinate as the center, which is k. So in order to use Pythagorean's theorem, we need to know distance. So we already know the distance of the hypotenuse. That's going to be r squared. So that stays the same. But our distance here and our distance here is different. And so in order to find this distance, we need to take the total distance, which we know this total distance is x, and subtract the other distance that we know here, which is a distance of h, because then we're left with that distance there, which turns out to be x minus h. So there's the distance of one leg, and then we're going to do the similar kind of way of solving the following distance here, this distance for this leg. So we know the total distance is a height of y, and I should have drawn that maybe over on this side on the axis. So we know that is a total distance of y, and then we know that this is a distance of k. So if we take y and we subtract k from it, it leaves us with this little piece, which we know is this distance here. So that gives us our two legs. One leg is x minus h, and the other one is y minus k, and we can then plug that into the Pythagorean theorem. So we will have x minus h squared plus y minus k squared. So just similar as to what we had up at the top here. However, we had to find this distance a little bit differently, because it wasn't just from a center of 0, it was moved over. And what we've actually found here is the standard form, the equation of a circle. The reason it's standard is because it doesn't matter where the center is. It can be shifted all over the place. It can even be placed back to 0. So let's say, for example, if HK was the center and the center was 0, 0, if I go ahead and plug in that value for the center, what am I left with? X minus h, which is, x minus 0, which is 0, and y, not 0, x, and then y minus 0, which is y. So look at that. I'm left with that same equation, which we said was for the circle that's centered at 0, 0. So this standard form with the h and the k gives us any circle no matter what the center is. And that's going to be the form that we're going to use in order to graph our circles, or to take any circle and then be able to write the equation. So for example here, this is a circle, and what we need to know, if this is our standard form, x minus h squared, I'm just rewriting it up at the top here, what we need to know is what is our center, so we can plug in h and k, and what is our radius, because then we are left with a function. Remember, a function has two variables, an input and an output variable, x and y. So we need to solve for h, k, and r. H and k are the center. So if I look at this circle, I can see pretty easily in this case, my center is going to be the point 0, 0. So I can go ahead and say that my h is going to be 0, my k is going to be 0. And then what I need to do is figure out my radius. And so the radius is the distance from the center to the outer edge of the circle. So if I just draw a straight line from there, the distance will be 4. And no matter where I draw that line, I can even draw a line here, draw a line there, draw a line there. By definition of a circle, that distance is going to be the same all the way through, which is going to be r equal to 4. So now I just take those two values, plug it in. It gives me x minus 0 squared plus y minus 0 squared is equal to 4 squared. I can simplify this to just make it look a little bit neater. X squared plus y squared is equal to 16. And that is my standard form equation of the circle. Now in the next circle here, I see that it is not centered at the origin, so the center is moved. That means my h and my k are not going to be 0, 0. It's going to be some other number. If I look at the circle, I can see it's right there. That's the center, where it's equally distant all the way through. Another thing you can do is just kind of find this total distance and then cut it in half, and so that can help you find that center. But we can see that our center, our h and our k, is going to be 2, 3. So that means h is equal to 2 and k is equal to 3. And then our radius, if I just draw from the center a line out to the circle, that line has a distance of 2 because we're going from 2 to 4. So I know my radius is equal to 2. And it's the same even if I measure up like that. If I measure over to the side there, that's a distance of 2 either way. So I'm going to plug it into that standard form. So we have x minus h. My h is 2, so we have x minus 2 squared, plus y minus k. My k is 3, so that is 3 squared, and that's equal to r squared. My r is 2, so 2 squared. In this case, there's not much simplifying going on over on the left side, but I'm just going to rewrite it so I can simplify. 2 squared is equal to 4. And there is our standard form, our equation of the circle. All right, now we have seen the general form of a circle before when we were classifying between ellipses, hyperbolas, or parabolas or circles. Remember, they have the same coefficient. Their coefficients are equal and same signs. And so we're going to go through the process of taking it from that general form where those coefficients are equal and then turning it into the standard form where you see that it's compact here, right? All those two are squared, rather than this being spread out as x squared plus y squared and so forth, right? So in order for us to do that, to get to that point, we need to make sure we're comfortable with the process of completing the square. And what that means is, for example, here, this is already a perfect square. It's x plus 5 being perfectly squared, which is x plus 5 times x plus 5. And if we distribute everything, kind of go through and FOIL it out, we get x squared plus 10x plus 25. So now I know that I can say that is a perfect square. I can take this and transform it into that perfect square. So that's the idea here, is that the general form, if you can recall, is extended out in this way or in a similar way. But if you look at the standard form, it's condensed, right? We have this condensed part here. And so we're going to be learning or reviewing the process of taking it from this point over here to a more compact perfect square. And in another example here where we kind of just generalize it with a number n, if we were to FOIL this out, we would get x squared plus 2nx plus n squared. So this kind of almost just gives us a pattern to go with, right? As long as you can figure out, if you have this extended form, as long as you can figure out what n is, then you can just take it and write it in that compact form for the perfect square. So it brings us to this next part here, which is figuring out the pattern and applying the pattern. So if you notice, in this case, we always kind of just ignore the x here and just think about what number you have there. And so whatever number, in this case we have 10, in order to figure out what n is, we would just need to take that 10 and divide it by 2. So that would give us 5. So 5 is the number that we're going to be working with as representative of that n. So I know that I can go ahead and just place a 5 there, and that's going to work. And then over here in this next blank space, it's n squared. So 5 squared is equal to 25. So that's what I'm going to go ahead and place in that position there. And you can, go back to this first example where we actually did take x plus 5 squared and we FOILed it out, and notice that we got x squared plus 10x plus 25. Well, that's where that 25 is coming from. So we are going to be using this pattern to take a fragmented portion like this to a then compact portion that you see there, x plus 5 squared. And again, we're going to just kind of follow the pattern here. So in order to figure out what this missing space is, we just take 2n, so that means whatever number is there, divided by 2. Obviously in this case, n is going to be our solution. And so in this square here, it's just going to be n squared. Okay, So that's just going to be the same pattern that we repeat over and over again when it comes to going from the general form to the standard form. So we can see here this is the general form of a circle, because when you look at the x squared and the y squared terms, they have the same coefficient and they're the same sign. So it's not something such as if you had like this instead, this would be an ellipse because they have different coefficients, but they're the same sign. So this would not be a circle. This we would have to, we're going to see how we take those ellipses and put those into standard form later on. But for now, we can see that this general form is in fact a circle. And so here are all of the steps to getting from this general form to this standard form. You can see here that this is all written out in the way that we figured out before. X minus h squared plus y minus k squared equal to r squared. This is that same format. We just have a value for h and k already plugged in and a value for r already plugged in. So let's go back and see what this process really is. And the first step that we have to make is notice what is an x term and what is a y term. Okay, and anything else that is not an x or a y, we want to pay attention to what that is as well. So there we have that. We want to put all of the x terms together near each other. So there's, oh, I used the wrong color, blue. There's my two x's that I had highlighted in blue. And then here are my two y's that I had highlighted in blue. I put those together. And then anything that is not an x or a y term, so in this case that negative 11, I have to move to the other side. So to get negative 11 to the other side, I had to add it. So it became a positive 11 on the right side. So what you should notice now is blocking everything else, right? Just kind of ignoring what you see there and paying attention closely to just what you notice there. X squared plus 2x. That should look just like what we did over here, right? Where you just have those two terms and then you need to figure out what this value here is. So how did we figure that out? We took this number here that's multiplying x and we divided it by 2. So over in this step, the number that I see there is 2. So 2 divided by 2 gives me 1. So you see that I've added a 1 there. So that gives us that perfect square format. Well, we can turn it into a perfect square. X squared plus 2x plus 1 will then become x plus 1 squared. And sorry, actually, this one is kind of confusing because this 1, when you square it, gives you this one. So we're going to look at the y's also to kind of see where this kind of takes us. But you can see here that these are equal to each other. Okay. And then over on the y's, I covered it up, and now I'm going to uncover it. Let's do a different color here, purple. Y squared minus 4y blank. So we need to figure out what this blank number is. And remember, actually, that one is the n squared term. So, because it's that third term. So we want to take what we see in the middle, that's negative 4, divide that by 2, and that gives us negative 2, which we then want to squared, gives us 4. So that's where this 4 is coming from here. Okay. So far we've found the 1 and we found the 4 and we've added them to our equation. But the problem is an equation needs balance, right? And this equal sign needs to have the same amount on one side as it does on the other side. And right now when we add a 1 and we add a 4, we're making this side a little bit heavier. So we need to get the equal weight on the other side, which is why if you look here, I've added a 1 and a 4. So it becomes 11 because we already had that 11 plus 1 plus 4. Now that we've added that to either side, we have completed our squares that we needed. That's a perfect square, and that's a perfect square. And so we can go ahead and transform that into our perfect squares. And on the other side, 11 plus 1 plus 4 equals 16. So there we have our first example there. This is now in standard form. We can figure out our center by determining what h and k are. So remember that this is x minus h and y minus k squared. So that means that you want to think opposite. If it's x plus 1, that means it's actually, your h is going to be a negative 1. And if it's y minus 2, that means your k is actually a positive 2. On the other hand, for the radius, all you have to do is square root that number, and that gives you your r value, which is 4 in this case. Now that we've done an example, kind of walked through it, and we're going to do a couple more together to really get a handle on all of the steps. So this is our general form of the circle. We see that it has the same coefficients, same sign. So the first step is get all the x's together, get all the y's together. Everything else goes to the other side. So x squared plus 2x, and I'm going to go ahead and leave that little blank space there that I know I'm going to have to find. And then y squared plus 4y plus blank space. Minus 20, I'm going to add it to the other side, and I have a positive 20 on that side now. So that was my first step. Get all my x's together, all the y's together, everything else gets pushed over to the other side. And from here, I need to figure out what those blank spaces are going to be. So if I take this 2 and I divide that by 2, that gives me 1, and then I need to square that. So 1 squared is equal to 1. So actually, again, I got another 1 over here. Now what I'm going to do at the same time is start to keep balance. So if I'm already adding a 1 over here, I'm going to already add a 1 on the other side. Next, I need to complete the square. If I have my middle term is 4, 4 divided by 2 is 2, and then when I square that, I get 4. So this 4 is going to complete the square for me, and I need to add it onto the other side. And now I can simplify this. So this x squared plus 2x plus 1 is going to become x plus something squared, and that something is just this 2 divided by 2, which is a positive 1. So that completes that square. Over on the y side, this 4 divided by 2 is equal to positive 2, so that completes my square there. And on the other side, I have 25. If you're ever having doubts about your completed square and you're not sure if it's the correct one, don't be afraid to just do a quick FOIL. X plus 1 times x plus 1. When you FOIL this out, you get x squared plus x plus 1 squared. Well, that's going to simplify to x squared plus 2x plus 1, which is what we started out with here. So you know that that is a correct perfect square that we've come up with. And that gives us our standard form. Awesome. Now we need to find the center, which is at HK. and that's going to be this number right here and this number right there. But remember, think opposite. So that will give us -1, comma, -2. And the radius is just going to be this number on this side square rooted. So the square root of 25 means r is equal to 5. So those are my two values for center and radius. With those values, and see how easy it was to find those values from the standard form. If we were to just have this general form, there's no way for us to figure out what the center or radius would be. So that's why it's helpful to know this process, so we can figure out the center and the radius, and then we can graph our circle. So we start with the center. The center is -1, -2. So I'm going to say this is -1 right here. So that means this is -2. So that point is right here. Sorry, it's kind of overlapping the number. But there's my point, so that means I'm going, each square is 1 unit. My radius is 5. So all I need to do, the easiest thing to do is count out 1, 2, 3, 4, 5. So that's going to be the edge of my circle right here. I'm going to draw it a point, and then I'm going to do the same thing in just all 4 directions. So 1, 2, 3, 4, 5. There's going to be my next point, and so then 1, 2, 3, 4, 5. There's the next one. 1, 2, 3, 4, 5. And there we go. That's the easiest way to do it, because we know the radius is 5, and then we just connect the dots to get our lovely circle, or as lovely as a circle as you can possibly get. Alright, let's do the next problem. So again, x is together, y is together. So in this case, the only x I have is this x squared right here. What that means is it's already a perfect square. You get to save yourself some work. This is automatically x minus 0 squared, which is awesome. And that was because there was only one x term. Your y's are all together already. Remember, you're going to have to add something extra there to be able to complete the square. And then you don't have any other values, just 0 on the other side. So that makes things a little bit easier to work with. We need to find this empty space here. So what we will do is we'll take -4, divide it by 2, and square it. That's going to give us -2, and then squared it becomes 4. So 4 is that empty space value, and so that means that if I'm adding a 4 on the left side, I have to add a 4 to the right side. So that was easy because we didn't have to do it to the x's, and now these will become y minus 2 squared. Now, how did I find that -2? Remember, it's just this part right here. -4 divided by 2 gives me that number, -2. And then on the other side, 0 plus 4 is equal to 4. That is my standard form. Now, my center is HK, which I can see here. My H is 0. Pretty easy. And then my K is going to be the opposite from what I see, so it's got to be a +2. The radius is going to be the square root of my number there, so the square root of 4, which is 2. So I have a radius of 2 with a center 0, 2. So I'm going to go ahead and graph this now. 0, 2 puts me right up there, and a radius of 2. So that means I'm just going to count out 1, 2, 1, 2 in either direction, 1, 2, and 1, 2. plot those points. And connect the dots. There we go. There is our perfect little circle there. And last example. So this one we are going to have to isolate. We see these X's here, and then we see the Y's here. The 2 is already on the other side, so that's kind of nice, but we've got to get those X's together and then know that we're going to need to leave a space. Then we've got the Y's together, but know that we're going to need to leave a space, and then 2 is on the other side. So we are going to go ahead and go for it, complete the square. So -6 is in the middle. I must divide it by 2 and then square it. So -6 divided by 2 is -3. -3 squared is 9. So I know I'm going to need to add a 9 on that side. Now, here, -10 divided by 2 and then squared. That's going to be -5. -5 squared is 25. So I'm going to add 25 there, and I'm going to have to add 25 right over there. So moving on, moving forward, we are just going to have to simplify on the right hand side and do our perfect squares on the left hand side. So I know this is going to be x all squared plus y all squared equal to 36. Now I just need to figure out this number here, which easily is just what I had in here. -6 divided by 2 is -3. And then right in here is -10 divided by 2 is -5. And voila, there is our standard form. So, center is h, comma, k. Is this point right there and right there. Think opposite, so that means we have 3, 5. And our radius is going to be the square root of 36, which is 6. So there is our center and radius. Let's go ahead and graph. So center 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. That means we have a point right there. Let's switch color to draw in the radius. The radius is 6. So I just need to count out 6 in either direction. So 1, 2, 3, 4, 5, 6. There's 1 point. 1, 2, 3, 4, 5, 6. I had to go out a little bit there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Ta-da! There's our circle. And that completes our lesson. So please make sure you follow along and are understanding this pattern here that I talked about. If you find that you are struggling with following along with what we are doing in here, because once you understand that pattern, hopefully things will kind of make sense as to how we're getting from this step here to that step there. But like always, let me know if you have any questions, and I hope you have a great rest of your day. Goodbye.